Hello, I'm Kevin Clausen. Thank you for viewing this video presentation entitled Introducing EMC XtremCache for Oracle Real Application Clusters. Agenda. I'm going to cover what does XtremCache do and how does it do it. I'm also announcing that there's a future video presentation where I'll cover how well XtremCache does what it does. So, what does it do, how does it do it, and how well does it do it? Well, simply put, XtremCache accelerates any application that benefits from low latency, high bandwidth physical read I/O. But we're here to talk about XtremCache with real application clusters, so you must be thinking, wait, databases do writes, and yes, that's true. So we'll get to some words about that in a moment. In fact, I'll start right now. See, XtremCache improves SAN array effectiveness, and that's because arrays that are relieved of read IOPS have more bandwidth to handle writes. That's true. Now, beyond that, there are specialized benefits for particular EMC arrays. Features like optimized read miss and full track read. Now, unfortunately, those topics specifically are outside the scope of this presentation, and indeed, that list is not fixed. I invite you to contact your EMC account reps to get more information about those specific topics, especially after you've viewed this introduction. When it comes down to it, XtremCache really is just a natural progression of storage acceleration. For ages, enterprise class intelligent arrays have offered tiers of storage ranging from high capacity slow SATA, nearline SAS, or 15K RPM fiber channel or SAS drives, or even array level flash assets such as enterprise flash disks or what have you. However, all of that has always been at the end of a storage communications medium and protocol such as fiber channel. Well, XtremCache promotes the hottest data to be stored right with the server flash. So it's just a complement to fully automated storage tiering. So what you end up with is an ultra performance tier. The hottest data resides on the server. And with modern servers, that's really where the data belongs. XtremCache, how does it do it? Before we can go very much further, we have to take a look at a cache model primer. The topics at hand are what to cache, what type of cache is XtremCache, and some words about cluster cache coherency. Well, it's really simple. With XtremCache, one caches Oracle data files only, not redo logs or clusterware or archived logs or any other such ancillary files. Only Oracle data files. What type of cache is XtremCache? It's a write-through cache. I'll have more words on that matter as we go through the presentation. And cluster cache coherency. Well, yes, we're talking about XtremCache in conjunction with real application clusters. So certainly there must be shared data coherency. And indeed, shared data coherency is maintained by XtremCache for Oracle real application clusters. As we go through the presentation, I'll make it clear just how that is. Let's take a look at a processing overview of XtremCache. The first thing we'll look at is an overview of an application read. This particular example is of a cache hit. So an application issues a system call to read a block of data that resides in a LUN being accelerated by XtremCache. Being a kernel driver, XtremCache determines that the data is in the cache and therefore accesses the data from the flash device, and the data is returned from the flash device to the application. Now, it's important to note at this stage that all of this processing occurred at the host. There has been no interaction with the downwind array. This is offloading of read activity, a physical read that was offloaded from the SAN back to the host, exactly where it should be done on modern servers. So that's a cache hit. What about a cache miss? So an application issues the same type of system call for a block of data in an XtremCache accelerated LUN, but this time XtremCache determines that the data is not in the cache and therefore accesses data from the LUN through the SAN HBA as the diagram shows. Data is returned from the array to the application. Then a copy is inserted into flash cache for future reuse. Now this is critical to point out because the application received the data without paying for the cost of XtremCache copying the data into the flash device. Indeed, if the application had to wait for the cache insertion, well, that's sort of like a tax being paid by the application, and well, that's just not good performance architecture. In Oracle terminology, one can picture this being an Oracle foreground process doing something like a single block read, a DB file sequential read, or even a direct path read into the PGA of the process. So having discussed both types of read, cache hit and cache miss, it's time to look at a write example. So an application issues a write system call to write a block of data in a LUN being accelerated by XtremCache. In Oracle, that would be database writer in DB file parallel write, or even a foreground process in a direct path write. In kernel mode, XtremCache traps the write request and asynchronously, concurrently, issues writes to both the downwind array, the LUN in persistent storage, and to the flash device. So this is concurrent activity, and if you will, the race is on. But the application does not get write completion acknowledgement until the data is in persistent storage on the LUN in the SAN. So the reason I put so much emphasis on this step 3 in the diagram is, well, XtremCache is a write-through cache, and indeed, until the persistent storage has been updated with the block, the application cannot receive completion acknowledgement. If that was the case, well then XtremCache would be a write-back cache, but no, XtremCache is a write-through cache. The application does not get completion acknowledgement until the SAN block has been updated. And now that I've established a solid foundation regarding the write-through nature of XtremCache, it's time to move on to the next section of the presentation, which is XtremCache, cache coherency with real application clusters. So, in a form of review, we've established that XtremCache is a write-through cache, and in a case of clusters, well, there's a need for shared data coherency. And indeed, coherency is maintained by XtremCache for real application clusters. So I feel that a cache coherency primer is in order. See, there are two important topics when discussing cache coherency. There's the performance overhead. For instance, who pays the tax? That is, who pays the tax for cache insertions? And who pays the tax for cache invalidations in a cluster? There's also the question of what happens when coherency is breached. And so of these two cache coherency topics, well, the performance overhead, the taxation paid for cache insertions and cache invalidations, well, that can be fairly subtle stuff, and mileage may vary. So if it's not done correctly by the cache software, well, it may not be as noticeable, but there's no secret. What happens when cache coherency is breached is glaringly obvious. There's either a service interruption or data corruption. So, no secrets here. Cache coherency is the most important aspect of clustered cache software. So, moving on. We're here to talk about real application clusters with XtremCache. So, well, we need to talk about clusterware. See, XtremCache cooperates with Oracle Clusterware. Oracle Clusterware is the final authority of all node membership information. Might as well just say that Oracle Clusterware is the cluster. That means there's no battling clusterware. Some of us may recall cluster architectures of yesteryear, for instance, Veritas Storage Foundation for Rack or HP Service Guard, what have you. Well, none of that comes into play with XtremCache and Rack. Now, however, XtremCache needs to ensure some order regarding accesses to LUNs being accelerated by XtremCache. So XtremCache uses SCSI-3 PGR to control node accesses to LUNs being accelerated by XtremCache. That is, only XtremCache nodes can access LUNs being accessed by XtremCache. This ensures that no rogue hosts can get in and foul up the cluster cache coherency. And that leads to the last point. So this is quite unique. See, XtremCache has no awareness of database instances. That is, XtremCache has no care or concern for the contents of blocks on cached LUNs. And this will become quite clear as I move through the presentation. So continuing the topic of cache coherency. In the case of real application clusters with XtremCache, well, there's roles and responsibilities. Allow me to explain. Rack owns block content coherency. See, Rack has the difficult work where the topic of cache coherency is concerned, because Rack does a good job of ensuring the coherency of rows and columns as they travel through the cluster. So Rack owns block content coherency, the difficult work. Now, on the other hand, XtremCache maintains block level coherency. So what do I mean by that? Well, to XtremCache, it's all about the block, not what's in the block. XtremCache doesn't care what's in blocks. XtremCache cares about state changes of a block. And because of that, there's no data shipping. XtremCache only uses metadata invalidation operations across the cluster to maintain coherency. And at that rate, the coherency overhead is outside database transaction scope. That's because it doesn't involve redo. Not only that it doesn't involve redo, I've already spoken a bit about the fact that it's database writer rights or foreground direct path rights that cause invalidations. Now, database writer rights, we all know, fall outside of transaction scope. Oracle has had deferred rights for block change rights for ages and ages. It's only redo rights that are physical I/O in transaction scope. And I've already mentioned that we don't espouse applying XtremCache to LUNs that have redo. XtremCache is for accelerating LUNs that have data files. That's index segments, block segments, and even lob segments for that matter. So data files are accelerated. And I'd like to say another word or two about the roles and responsibilities. So because XtremCache only has to send a nibble of metadata to other hosts that tell them to invalidate blocks in their XtremCache flashcards, well, that's not any perturbation on the network to speak of. Indeed, RAC itself with GCS, Global Cache Services, or Cache Fusion, is sending entire blocks of data around the cluster. That's not the operational method of XtremCache. XtremCache does not ship data. XtremCache only sends metadata invalidate messages. Oracle writes are equal. I'm drawing attention to the fact that cache coherency with XtremCache is anchored on data file writes. So we have to take yet another look at how there are differences in writes in Oracle and which are more important than others. A review for a lot of folks. See, not all Oracle writes are created equal. There are writes in transaction scope, that's log writer, log file parallel write, and there are writes not in transaction scope. Again, I've already mentioned DB file parallel write. And the most critical goal in making a high performance cache to accelerate Oracle is, well, never tax these. So I've already mentioned that redo has nothing to do with XtremCache, and therefore, for free, we don't tax the most critical IOs that happen in OLTP. So when it comes down to it, XtremCache really has no coherency work to do until database writer writes a modified block. Now, that's really where it's at. Database writer writes a block, and then XtremCache has some coherency effort to expend. But this changes the processing flow for writes. When we compare XtremCache to non-rack deployments to XtremCache with rack deployments. And so we have to take a moment and look at another processing flow schematic. And this is a familiar graphic. It's the same graphic that I used to introduce the life cycle of a write with XtremCache, but before I was just discussing the generic nature of a write with XtremCache without discussing real application clusters. Now, because real application clusters changes XtremCache a bit, having to do with cache coherency, I'd like to walk through this diagram as well. So here we are. A write request comes from an application. Let's say that that's a database writer DB file parallel write. Now at step 2, XtremCache traps the write request as before. However, now there are 3 operations that take place concurrently. One, well, the array LUN is updated down in the SAN. 2, the flash device that's local to the database writer who issued the write, well, that flash card has an old copy of the block, so it needs to be updated with the current copy. And in red, you'll notice on bullet number 2 here, I have performs cache coherency operations. Well, what is that? I've over here on the left in the orange box, I've listed out what that is. So for step 3, task 3 of step 2, remote cache invalidations, that consists of 1, the invalidation is sent to the peers that need to do invalidations. 2, those invalidations are processed, and 3, acknowledgement is received by XtremCache back on this host, that the acknowledgement that all of that transpired on the remote hosts. That's before we leave step number 2. Now, what happens next is database writer receives acknowledgement that his write is complete, and that means that what has happened is the array transfer is complete and the other hosts in the cluster have conducted their coherency operations. So cache is coherent, the SAN is updated, then DB writer is on his way. And again, Not to beat this over the head, but I'd like to draw focus once again to step number 2, especially task number 3, performs cache coherency operations. Well, that's a tax that's paid by database writer, and that tax is wall clock time that's added to database writer's asynchronous writes, but that's time outside of transaction scope. And again, it's all asynchronous. So DB file parallel write is where the tax is paid, not in transaction scope. So everybody viewing this video knows a lot more about XtremCache now, but somebody is going to view this and ask, well, why can't I just use Oracle Database Smart Flash Cache? Well, you can, but the comparison comes down to just how comprehensive different cache solutions are. There's no better way to make the point that XtremCache is comprehensive than to throw up a table, so I'm going to do that. Now, under XtremCache heading, we can see right off the bat that operating system support really matters. See, XtremCache supports Red Hat distributions as well as OEL, although not the Unbreakable Enterprise kernel just yet. So Red Hat Enterprise Linux, OEL, Windows, VMware, plus there's Roadmap, whereas Database Smart Flash Cache really is only OEL and Solaris. And then there's this unique characteristic I've been speaking about, and that is how the cache relates to databases. With XtremCache, XtremCache knows nothing about databases. It only cares about blocks in LUNs. Well, to the contrary, Database Smart Flash Cache is an association of cache to a single database. So if, for instance, you wish to have 20 databases in a consolidation environment, you'll have to figure out how to provision um, partitions from flash devices, 20 different partitions from flash devices to 20 different databases, because it's a relationship between database and flash card, as opposed to XtremCache, which is a relationship between LUNs and XtremCache. So if, for instance, there's capacity for 100 databases in the LUNs being accelerated by XtremCache, they all get the treatment of XtremCache. And I'll add, everybody knows that with Oracle Clusterware, there is full-fledged support for running prior version database with current version clusterware. An example, 11G R2 clusterware fully supports running 10G database instances underneath it. So what does this mean? Well, this means that you can have 11G and 10G databases living in accelerated LUNs, all being accelerated by XtremCache. And that's just simply not the case with a single database to flash relationship like you get with Database Smart Flash Cache. Then there comes the comparison of what gets cached and when. It's pretty simple to see, right? Everything with XtremCache is cached. Single block PGA or SGA reads, multi-block SGA PGA reads, all cached. Extreme Software Cache, not cached. And it really comes down to what happens with database writer writes. So I just finished a section where I brought up the fact that database writer writes with XtremCache trigger a coherency mechanism in the XtremCache driver. Well, it's entirely different with Database Smart Flash Cache. See, Database writer writes in Database Smart Flash Cache, that's the sole method in which data gets into the cache. And that includes blocks of data that are read into the SGA and age out clean. It's database writer that has to fill the cache. And therefore, only data that flows through the SGA makes it into Database Smart Flash Cache. Well, what if, for instance, you'd like to accelerate a data warehouse, full scans? Indeed, with XtremCache, you can have multiple flash cards hosting data being scanned with parallel query at the delivery rate that is offered by PCI Gen 2 by 8 PCI cards. So an extreme amount of acceleration is available for scanning data, for ETL, ELT. All of these sorts of operations are accelerated by XtremCache, and that's because XtremCache is comprehensive. So I spoke about it a little bit while I was just covering this table of database smart flash cache, but I really want to drive home operational uniqueness with XtremCache. And again, XtremCache is not associated with database instances. Indeed, XtremCache doesn't know anything about databases. It doesn't care. This is a strength. This is a strength because cached LUNs can have can have data files from as many databases as you desire. If your LUNs are multi-terabyte in size and you have thousands of databases inside of those LUNs, they get treatment from XtremCache. I just want to make that point clear. Now, operationally, it's important to visualize the fact that XtremCache can be started and stopped globally without database service outage. And again, this goes back to the point I keep making, which is, see, XtremCache doesn't know anything about databases, and databases don't know anything about XtremCache. So if you so wish, you can start and stop XtremCache, and database service continues on its way. Albeit, if you shut down cache, well, the database reads will be higher latency, but if you start cache back up over time, those IOs will start to get trapped and placed into the flash card and accelerated accordingly. So not only is XtremCache independent of databases, databases are independent of XtremCache. It's equal. So database instances can be started and stopped with no concern for XtremCache. So if you so wish, you could just have a continual start and stop of XtremCache and database start and stop. So if you have a consolidation environment where databases need to be start and stopped in order to be patched or what have you, no care or concern for dealing with XtremCache because instances are independent of XtremCache. And although I mentioned it a moment ago, I would like to cite a reference. See, this My Oracle Support tech note is actually the final authority on the fact that, well, you can have, for instance, 11.2 clusterware with 11.2 ASM and store Oracle 10G databases inside of those storage assets. And this is why it's so very easy to have mixed version databases that are being, and any number of databases being accelerated by XtremCache. And this will continue in the future. Future releases of XtremCache will support 12G cluster, 12C clusterware, and 12C clusterware allows databases of 11.2, 11.1, and 10G. And the reason I think that's so important is because once someone adopts XtremCache, well, they can advance the clusterware, and as their applications are certified for future revisions of the database, they adopt that revision of the database, and their cache model remains fully intact. No large rip out and replace sort of scenarios. And this brings us to summary. So, XtremCache. XtremCache really is just a natural progression of storage architecture. What's going on here is EMC is taking performance beyond enterprise flash drives and even the DRAM of enterprise class arrays and moving those reads back up to the host where they really belong. Today's hosts are incredibly capable of moving data from memory to CPU. This is not the era of front-side bus bound systems. These are extremely high bandwidth CPU to memory systems. So keep the keep the reads up at the host. Don't bother the downwind SAN array with reads. Right? So it's just a natural progression of accelerating storage. And XtremCache maintains cache coherency across clustered nodes. Well, it has to, right? If it didn't do that, one would suffer data corruption and service outages. So it's really quite simple. It's shared data clustering. It must maintain cache coherency. But the way that's done is metadata invalidates only. This product, XtremCache, does not ship data. That's the space where rack shows its value. Rack ships blocks of data around in its cache fusion functionality. And XtremCache accelerates real application clusters performance. Of course it does. And the way it does that is by, as I said, offloading reads back to today's very capable hosts. And that keeps the data as close to the CPU as any storage model will allow. We're talking about a progression of storage here. This is still storage. These are cached blocks from LUNs. This is not in memory or any other such thing. This is accelerated storage. But the reason it works is because this product doesn't tax active transactions for cache insertions nor for cache coherency. And of course, it's extremely flexible and simple to provision flash cache to arbitrary numbers of databases of varying Oracle releases. Extremely flexible and extremely powerful. And with that, I would like to conclude this presentation. Thank you.